Hello, happy Quadratics Day 5. I just cleared my calculator out, so I'm ready to go for today. Happy Monday. We're a week into this, and we're going to keep plugging along and figuring out a little bit more each day about quadratic functions. So we're going to use what we used on Friday, which was called that zero product rule today. Looks like I just crossed it off, but that is what we're learning. And I want you to see that we can use that zero product rule as long as we have our equations equal to 0 and you have the product of two factors, or really more, will be equal to that 0. We know one of the factors would have to be equal to 0. So first, to begin today, let's start with a warm-up of just factoring. So just one quick reminder, when I say factor, the first thing you should think is GCF. So let's go in that order of looking for the how to factor all of these. The first thing we do is GCF. Second thing we should look for is DOPS, the difference of two perfect squares. None of these have the two terms, so that's not going to be a case here. It could be once we factor it out the first time. We can always check that and then check to see if it's a trinomial. In the last unit, we factored trinomials, multiplying to get the last number, adding up to get the middle. And then we also had trinomials where a was greater than 1, and we thought about how we could possibly get that, organizing in the box method, or we use something called group factoring to find the products or the factors as well. So go ahead and pause the video to try to factor A, B, and C. So when you're factoring, sometimes there are different strategies, but generally the main idea is that you do have to go through and check to see if there is a GCF first. There is no GCF of these three terms, and it's not the difference of two perfect squares. I noticed that it is a trinomial. There are three terms, and in fact it's a quadratic expression because it's got x squared. And what I'm going to have to look for is when I'm asked to factor, I want to know what's going to multiply to get that result. So I'll think about 12. How might I multiply to get 12? The factors of 12 are 1 and 12, 2 and 6, 3 and 4, and now I've gone through all of them. I need to come up with one of these pairs of numbers that will add up to a negative. So since I want a positive 12, they can either both be positive or they both can be negative, but they must be the same sign. Since I want to add to a negative number, they're going to have to both be negative. So it looks like I can get a 7 by using 3 and 4, and if they're both negative, that will be negative 7. So my one factor is x minus 3, and my other factor is x minus 4. So I've completely factored the first one. Second one, always check for GCF first. There is a GCF. We can take out a 2 of all three terms. So once I factor out that 2, remember that that now is a factor. So my end answer still has to have that GCF out front. Now we need to determine what the other two factors are. Notice we just did this one in the problem before. So 12, the factors that will work are 3 and 4, x minus 3, and x minus 4. And then for part C, the GCF, there isn't one. So that means we have a leading coefficient greater than 1. My suggestion would be right now to group factor, but if you want to think your way through it, totally will be fine as well. So I'll just remind you of how to group factor. We think of that first leading coefficient multiplied by the constant. So 2 times 2, we're going to use this number, 4, and we're going to think of the factors of 4, and we're going to split the middle. How can we use a pair of these numbers to come up with 5? I know that 1x and 4x would allow me to get 5. So again, I'm making and rewriting 5x. I'm really not changing the problem. I am just splitting the middle. Now I have 4 terms. So I'm going to take the first group and find its GCF. And then I'm going to take the second group and find its GCF. So the GCF of the first group has an x, and I'm left with 2x plus 1. The GCF of the second group is 2, and then I'm left with 2x plus 1. And remember, you should have common factors here. So one of the GCFs, or the GCF of these two would be 2x plus 1, and the stuff that's left over goes in the other factor. So that's a quick rundown of how to group factor. If you have more questions on that, let your teacher know and we can explain further about group factoring. But we're still mostly focused on being able to focus when factoring a trinomial and a GCF with a trinomial. This is more of an extension for us, at least at this point. So for example 1, we're going to solve the equation. We're going to again use the zero product rule, so it has to be equal to 0. Check. Now we need to come up with 2 factors. In other words, what are 2 things that multiply instead of writing 5x squared plus 2x? So we'll find the GCF. Now notice, there's no GCF between 5 and 2, but both of them have a variable. So the first GCF I can take out is x, and I'm left with 5x plus 2. Right now I have 2 factors. The first factor is x, and the second factor is 5x plus 2. What's going to make the first factor 0? A 0. So I have 2 factors. Either x can be 0, or 5x plus 2 will equal 0. So now we're going to have to look at, we can't just guess like we did the other day when we were finding out the factors and figure out what numbers would work. What we'll have to do is actually solve this equation. So we'll need to subtract 2. 5x equals negative 2. Divide both sides by 5. So x will equal negative 2/5. So basically, if I were to plug in negative 2/5 into this equation, right there for x and there for x, I would solve to get 0. If I plug a 0 in here and a 0 in here, I would solve to get 0. So there are 2 solutions, 2 roots, 2 ways that I can make this equation be equal to 0, when x is negative 2/5 and when x is 0. So let's solve the next one. We want to figure out what could I plug in for x to make it 0. So we're going to try to use the zero product rule. Set it equal to 0. We've done that. Now we want to find the factors. First thing you always look for when you say factor is the GCF. In fact, this one does have a GCF. So I'll factor out a 3 to start. And now I'm left with a trinomial. Again, remember that 3 still stays there because that is a factor of the original expression on the left-hand side of the equation. But I need to continue to factor this trinomial. So we think about what multiplies to 8. In other words, what are the factors of 8? And which of these pairs of numbers will help me get a 6? 2 and 4. So now I have factored out this original trinomial with the GCF, and then now that I had another trinomial, so I factored it out with those 2 binomials. So I actually have 3 factors that equal to 0. When can I make 3 equal to 0? Never. When can I make x plus 2 equal to 0? When x is negative 2. When can I make x plus 4 equal to 0? When x is negative 4. So there are 2 ways that I could plug a number in for x that make this original equation true. That's when x equals negative 4 and negative 2. It's okay if you write negative 2 first, then negative 4. I'm just going in order from least to greatest. For example 3, there is no GCF, because when you're factoring, you should always think about that. This is one of those more challenging ones where I'm going to group factor. So I'm going to take 3 and negative 10, find their product, and then I'm going to think about all the ways I can multiply to get negative 30. I know that one will have to be positive and one will have to be negative, because that's a negative. Okay, I have all the factors. How can I split this middle? Let me give myself a little bit more room here. How could I split that middle? I want 1x. One of them's got to be positive, one of them's got to be negative. So I'll want minus 5x and plus 6x. Together, that'll make 1. So again, with group factoring, you are just splitting the middle term into 2 different terms. Basically, from when we used to multiply binomial times binomial, there were 4 terms. We're figuring out what that other middle term was so that when we combine them, the result would be 1. Again, sorry, if this is difficult for you right now, don't stress about this one. So now I'm going to find the GCF of the first 2 terms and find the GCF of the second 2 terms. And if you have done it correctly, they both inside the parentheses should have something in common. And what's left over, oops, there's no equal sign there, that's just next to it, x plus 2 is the leftover, so that's the other factor. So I have factored this out into a set of 2 binomials, and I know their product is equal to 0. So again, the zero product rule tells me if you have two terms or two groups of terms that equal 0, I know that if their product is 0, one of them's got to be 0. So we find what would make the first factor 0 and what would make the second factor 0. Just realized you can't see the bottom. Sorry about that. So 3x equals 5 divided by 3. So my two answers that would work for example 3 are -2 and 5/3. Again, number 3 is more of a challenge question, knowing how to factor with a leading coefficient greater than 1. I am not super worried about this one at this point, okay? You should focus on number 1 and number 2. So now we're going to solve the following equation, and this is one that you should be able to do, but notice that it is not equal to 0. So if I'm going to use the zero product rule, the first thing I need to do is set it equal to 0. So I'm going to move everything, in this case the 18, to the left side, so that I have on the right side just a plain old 0. I'm going to find two factors that multiply to get 0. So I need to think about what multiplies to get -18. Right away that tells me one of these will have to be positive and one will have to be negative. Okay, so which pair of numbers can I use to get a 7? So if I have a +9 and a -2, that'll give me my 7. So they multiply to get -18, and 9 minus 2 combining like terms will give me that 7x that I'm looking for. So the zero product rule tells me that the product of these two equals 0. The first factor will be 0 when x is -9, and the second factor will be 0 when x is +2. So the two solutions to this particular equation are when x is -9 and x equals +2. So on this page, you'll want to make sure you know how to factor out A, B, and then you'll want to make sure you understood examples 1, 2, and 4 specifically, okay? All right, let's go to two other types of ways they could ask this type of question, and they're more the word problems. So the area of a rectangle, okay, as soon as I see the word about a shape, I'm going to draw the rectangle so I have a visual. So the area is expressed by x squared plus 2x minus 3. So I'm actually going to write that into my rectangle because area is the amount that's inside the rectangle. Write each dimension of this rectangle as a binomial and then the area in terms of the product of the two binomials. So area of a rectangle is length times width. Basically, I'm asking what's this length and what's this length. And because it's a trinomial, I basically just want to know what the product is or what the factors are that will give me that result. So we think about ways we can multiply and get -3. How can I take these numbers and get a 2? I can do a +2, so I need x plus 3 and x minus 1. X times x is x squared. We got 3x minus 1x gives me my 2x, and 3 times -1 would be the -3. So I have factored this correctly. So we can call either one the length and either one the width. But there's the length and the width. So suppose the area's rectangle, or the rectangle's area, is known to be 21 square units. So we know that x squared plus 2x actually is 21. So write an equation that is equal to 0 and solve it. So right now it's not equal to 0. So just like on the last page with example 4, I'll need to move that constant over to be with the other constant, and I'll have x squared plus 2x minus 24 equals 0. Now, the zero product rule is very helpful if you can factor it. So I have it equal to 0. Notice that it said set equal to 0, which was the first step in using the zero product rule. Now that I have it equal to 0, we will factor it out. So it'll be x. Oh, I need to think about all the ways to get 24. And it looks to be like one's going to have to be positive, one's going to have to be negative. I think 4 and 6 will help me. So there are my two products that equal to 0. So the zero product rule says that either factor has got to be equal to 0. So when x is 4, it'll be equal to 0. When x is negative 6, it'll be equal to 0. So there are two ways that I can make this equation equal to 0. Okay, what are the actual dimensions? Well, we determined that the length from up above is x plus 3. We had two choices here. Our first choice was negative 6, but negative 6 plus negative 3 would mean the length is negative 3, and we can't have a length that's negative. So negative 6 will end up being an incorrect answer because we can't have a negative length. That means for the length, we know we have to use 4. So 4 plus 3 equals 7. Okay, so we know the length is 7. And then the width is x minus 1. And again, negative 6 would give us a negative number, not okay. So we're going to have to use the 4. So the width is 3. And if you notice, 7 times 3 is 21. So we just figured out the relationship by setting it up with that trinomial and finding the factors and then substituting our solutions in to actually determine the actual lengths. So the dimensions are 3 by 7. Okay. This was a fancy old Regents question that we saw not too long ago. A rectangular garden measures 12 meters by 12 meters by 16 meters, and is to have a walkway installed around it to have a width of x meters. Together, the walkway and the garden have an area of 396 square meters. So the whole area is 396. Write an equation to find x, the width of the walkway. I basically need to know what's this complete length and what is this complete length or width. So we know that this length of the garden is 16. So we know it's going to be more than 16. How much more? This length, same length as down here, is an extra x, unknown amount, and the same unknown amount over here. So we can write x plus x, or you can leave it as 16 plus 2x. On the left-hand side, this garden is 12 plus an amount that's unknown x, plus another amount that's unknown x. So there's the length there, 12 plus 2x. Okay, so we can find out that the area of this big rectangle, which has this as a dimension and this as a dimension, when I multiply them, that's the area. That result will be 396. Okay, so we can take 16 times 12, 16 times 2x, 2x times 12, and 2x times 2x. Okay, when I'm going to use a zero product rule, you do always want to have it equal to 0. So I'm going to move the 396 over. So I've gotten equal to 0, but I feel like we should probably put this in order. So 4x squared, combine those, that's 56x, minus 204 will be equal to 0. If we're going to use a zero product rule, that means we factor. So factoring out, I will factor out the 4 because that is a GCF. And then I will continue to factor and think of what multiplies to give 51. Oh, I think I found it. 3 and 17. So x plus 17 and x minus 3. One of these factors will be equal to 0. 4 will never be equal to 0. When will x plus 17 be equal to 0? When x is negative 17. And when will x minus 3 be equal to 0? When x is 3. Now, we're not going to have a walkway that is a length of a negative amount. So the length of the walkway must be 3. Again, a little bit more of a challenging question because we had to set up the area, set it equal to 0, and we actually had to distribute before we could actually bring this 396 over, because otherwise you can't just put it in with these without distributing first. Now is a good time to practice on the next page for these 6 questions. I'm looking through. This one would be a challenge, so you don't have to do number 5, and you also don't have to do number 2 if you're struggling at all. So I would practice right now 1, 3, 4, and 6 to see if you are able to figure out how to use the 0 product rule to find the solutions. Okay, so pause the video, and then I will place the solutions to all of these. And you could pause it so you can see all of our work. Okay, and if there are questions, please feel free to email us. Again, do not stress too much about number 3 and number 5, but you can, again, practice using the 0 product rule just by focusing on setting it equal to 0 and then your practice of factoring. Okay, today's follow-up homework will be the Quadratics Day 5. I'm going to suggest for some of you to not do all of them. I'm going to say my recommendation is that you do number 1, and always a spiral review. I recommend you do number 1, number 3, number 5, just means you have to move the 3B over. And I'm going to recommend that you try number 8. Okay, so those are the ones that you're going to have to turn in for completion for the homework credit. But for the rest of them, those would be more of a challenge question. I would love it if you had questions on 8 to email us, and we can show you how to do that again. But that follows up with the one question we did about the rectangle in the notes. So again, try the spiral 1, 3, 5, and 8 for homework. Okay, have a great day.